Okay, welcome to Chapter 2. Today we will be talking about the payment management system levels as well as functions. So at the very beginning, let's first define what's payment management system. So the payment management system is simply a crucial decision-making process that is used to make cost-effective decisions about design, construction, maintenance, and even rehabilitation for pavements, which is something really important nowadays, especially with a very limited budget that we need to handle and use. So here is schematic for the payment management system flowchart. So the way the payment management system works is at the beginning you have to start with collecting what we call decision data. So decision data is basically some of the data like the payment performance, like what we studied in the previous chapter. For example, fatigue cracking. So we need to go to the field, observe what's going on in the field in terms of the performance, measure how much fatigue cracking was there over time, and then this data is going to tell us something. It's going to tell us is the pavement now deteriorating, and what's the actual amount of deterioration every year or every other year. And based on this is going to allow us to perform more of data analysis part to see what happened. So I can have two different sections here. Maybe a section with increasing flow of fatigue cracking over time versus another section that you would see the fatigue cracking was increasing and all of a sudden now it's going down, and then after a couple of years it starts to pick up again. And you may wonder what's the difference. And this is here where the data analysis would help you to define that the section with continuous data, continuous increasingly fatigue data, this is going to indicate that there was no additional maintenance over the years, while the other section that had improved fatigue cracking over the time, this will indicate that there was some maintenance that happened that decreased the fatigue cracking all of a sudden, and after several years it's gonna pick up again. So based on the data analysis, now we can generate information. Basically, information here in the form in the form of a report. So basically, we're gonna come up with a report, and which is gonna talk about what's the data that was collected, what's the analysis that was performed, and eventually, and this is what make a difference between an engineer and others, is to make a decision. So now you need to come up with a decision. For example, again, if you go ahead and recommend that you will need a chip seal for fixing low severity fatigue cracking, then this is the recommendation. You will do it in the field, and then you need to look for a feedback. So that feedback is gonna help us to see if that recommendation was the best one, or did we need maybe a more expensive solution such as 2 inches overlay or 3 inches overlay. So this is again gonna go all the way to the feedback process, going through the condition data again, because now once I have this chip seal, whether it's a chip seal or an overlay, it will improve this road condition for some time, and then we need to go back and take more data surveying, condition data, to know exactly now what was the effect of that treatment on the road, and then we're going to go through the same process again. So it's the same thing from the other side. The feedback is gonna require us to get more inventory data, which is gonna feed into the major data, the more fatigue data after the application of the maintenance activity, and then further analysis and so forth. Okay, so now the next question that you may ask me, why do we even need the payment management system? And in fact, so many engineers, when the payment management system idea was introduced in the last 20 or 30 years, was why do we even need it? And the answer was pretty clear, that the main reason was now we're really dealing with limited taxpayers' money, indicating that the budget is now limited. which is gonna really require us as an engineers to look for a more of a cost-effective methodology of deciding how to invest limited resources. So if we really have a lot of money back in the days, then we would do what we call reactive maintenance, which is basically a more costly options to do a major rehabilitation, or even you can just remove all the layers and reconstruct the road from the beginning. And again, that was really costly option, versus what we need to think of now is really a cost-effective maintenance option, which is proactive maintenance, meaning that it's really now we're concentrating on preventive maintenance. When I say preventive maintenance, is very minimal amount of maintenance activities, which is gonna keep the roadway condition in a high standards all the time. So we will not be able to, we will not be reaching a failure mode. So we don't have to spend a lot of dollars into rehabilitation or reconstruction. So the question now is again, how does the payment management system work? So let's take a look first on this graph here. The x-axis is the payment age from new, which is time 0 or new condition, all the way to old condition, and the y-axis is the payment condition. So this payment age and this is payment condition. And as you could see, the payment typically starts with a very good condition when we constructed, and then with time you would see that based on this line, we call this line deterioration curve, the performance or the condition of the payment is gonna degrade gradually with time until we reach what we call here a failure condition or a very poor condition. So how can we tie this into maintenance or repair activities? And this is gonna lead us now to the second graph right here. Now it's the same thing, payment condition, and this is the payment age, but now the payment condition with time, it's gonna allow us to really trigger certain types of maintenance activities. So the maintenance activities is gonna be related to the payment condition. For example, if I have a really good payment condition, then this is gonna trigger a very minor repairs will be required. For example, like what we talked about in chapter 1, we may be able to do minimal amount of seal coats or fog seal coats, or all the way to maybe chip seal. Now if I let the payment deteriorate more and I'm not gonna do anything until it reaches maybe this point, now this is gonna trigger more cost and more rigorous type of maintenance, all the way until I reach now the very poor condition, where now it's gonna require me to do a major repairs to fix the road. So in other words, going now to the third graph here, I have payment age, new and old, and the y-axis is payment condition. Now there are 4 major families of fixations, if you will, depending again on the payment condition. If the payment condition is really good, you can do a routine maintenance, very minimal. It's the cost is very low. And now going from routine maintenance to preventive maintenance. Preventive maintenance is again, you may see it's a chip seal or up to 1 or 1.5 inches overlay. Now if the road is really left for longer periods without any maintenance, now we have to do a major rehabilitation, which is including up to 4 or 5 inches overlay. And then the worst case scenario, if you really leave it until the pavement just fails completely, then you have to do a major reconstruction, which is gonna trigger a lot of money compared to if you really would keep the pavement into a very good condition all the time. So now shifting gears to the other topic here, which is the payment management system levels and functions. So what do we really mean by that? So historically, many highway agency managers and administrators have tended to view their highway systems as simply a collection of projects. So by viewing the network in this manner, there is certain comfort derived from the ability to match pavement conditions with their physical or functional needs. However, by only focusing on projects, opportunities for strategically managing entire road networks and asset needs are really overlooked. Although the bottom-up approach is analytically possible, managing networks this way can really be a daunting prospect. Instead, road agency administrators have tackled the network problem from the top down by allocating budgets and resources based on historic estimates of need. So this really tells you that this approach is a belief that the allocated resources will be wisely used and will prove adequate to achieve desirable network service levels. So again, that's what I'm trying to summarize here in a nutshell, like what I'm showing here, that the network really just address a broad pavement maintenance and rehabilitation questions. It's looking at the entire sections from one as one picture, and it gives a general guidance on funds, needs, and the level of treatment, which is again totally different than the second level, which we will be talking about regarding the project level. So what are the questions that the network level tend to answer? The very first question is, what is the current health of the payment network? We need to know exactly, is the payment network in general, is it in a good condition, fair condition, or is it failing? Second question would be, which pavement sections need work? Again, this is also after we collect the data, we need to define in groups. Okay, some of the sections need minimal work, some of the sections need an overlay, some other sections need a major reconstruction. So this is the other question that we need to answer from the level of network. The third question would be, which sections should be worked on first? And we will be talking about this in a minute. There are two schools of thoughts when it comes to fixing the road. Which roads we should fix first, the good roads or the bad roads? And also the other question is, how much money do we need to fix these network or these roads? The last question here is, what impact will funding changes have? So the amount of money that we're gonna put is gonna improve the network pretty significantly or not much of improvements. So all these questions need to be answered from the network level perspective. So the primary products of network level analysis is basically what we call fund needs. Why do we need funds? Sometimes again we need to come up with these analysis to justify why we're asking for such funds. And also we need, as a product, we need to have forecasted future conditions. Again, and this we cannot do this really unless if we have a good record of all the data in the last 20 or 30 years, which is going to allow us to predict the payment performance in the future. And the third product will be prioritized listings. So a list of the major issues that we have, and also a list of the how can we fix those roads in the best way, and also deferred treatment information. So here again, this is to give you a full perspective of the network level flow chart, if you will. So the very beginning, as I said, everything related to payment management systems has to start with a data collection. We have to gather data, which either it's both road inventory as well as condition survey. When I say road inventory, is basically how many lanes, what's the width of the lanes, the cross-section properties, and so on and so forth. And then also you need to collect condition survey. The condition survey is mainly what we discussed in chapter 1. Basically, what are the distresses that the pavement is facing, and the severity and extent of each one of those distresses. Then we need to analyze the data. After the analysis, in fact, as a result of the analysis, we need to recommend repair strategies, as well as generating reports. And based on the reports and our recommendations, then we will develop the budget to fix those issues using the recommended treatments that you asked for. And eventually, we also have to go through a feedback process to feed back all the way to the surface here, or to the very first stage, to gather more data and improve the system one more time. Okay, now we're gonna move to the next type, or the next level of payment management system, is the project level PMS analysis. Now, instead of looking at the network, let's pick on Tyler as the entire city of Tyler as a network. Now, looking into the project level, it's more detailed on more concentrated look into one single project at a time. So during the analysis, we will really go through an engineering analysis and design for that project, and eventually we need to determine the most cost-effective alternative for the specific sections of pavement within available funds, and of course constraints. What I mean by constraints is more of what's the amount of assigned budget that we are assigned to use, and how can we come up with solutions based on it. So the flow chart, when it comes to the primary products of the project level, first of all, again, I think the picture here, I showed it in chapter 1. This is to show the cause of the deterioration. Once you gather the data, you need to know what's the reason behind having such problem, which is gonna eventually allow you to discuss with the other engineers, with other engineers, what would be the possible strategies to fix that problem, and eventually you would need to select the best one to go for. So again, this is the level information when it comes to the project PMS level. First of all, again, you need to identify how many projects, project 1, 2, 3, 4. You need to gather the data, and again, the data has to include up-close survey. Now it's very concentrated on this project or projects in particular. We need to have a good amount of field measurements when it comes to severity and extent of each distress that we see. We also would take soil and pavement samples. You see now, what I want you to see the difference between network level to the project level. Project level is really a much closer look into certain project or two, and that's why we would go to close survey, field measurements, all the way to cores. When I say soil slash pavement samples, we would go and take some cores to know, for example, if we have rutting, is it coming from the soil or is it coming from the pavement or the HMA layer? So all the way to investigating an existing conditions. Once we gather all this information, this will allow us to do a comprehensive analysis, which is going to eventually list for us and finalize the project list, which is going to help to develop detailed scope of work. So the question here is, now in summary, we have two systems or two levels. We have network level, which is looking at the entire city as one shot, one general look into the condition of the network in general, or the payment management system from the project perspective, project level. But in general, either or network or project levels, they are all having common benefits, and the benefits for having a PMS for any city is really when we would have a more efficient use of available resources. Instead of just spending money in different techniques, now we're gonna have one unified way of coming up with a good decision making process to use the money in a wise and engineered way. we will be able, and we are having now the ability to justify and secure more funds, because we are having a clear understanding. If I gather good data for a good amount of time, now I would have a clear understanding of what are my needs and how can I justify the funds that I'm asking for. Also, one of the benefits is we're gonna get information on the road system. That's gonna allow me to know and predict the future performance. Also, I'm gonna be able to quantify the condition of the network and come up with the supportable needs analysis, as well as what's the impact of the fund decisions. If, for example, if I spend that much of money, what's that money is gonna be used for, and how is gonna pump up the health of the entire network in general. And lastly, on this slide at least, is gonna improve the MR strategies, the maintenance and rehabilitation strategies. Other benefits is gonna improve communication. Sometimes it's very hard to try to convince other engineers, or even within the same agency, that we need certain funds, or we need to do certain treatments at some roads and another type of treatment or another roads. And PMS would allow us to improve those communication, because it's one system. Everyone would access it, and everyone will be aware of the health of the network, and therefore the communication will be much easier. We will also have a good ability to answer what if questions. Sometimes being an engineer, you cannot just come up with one single solution. Having several solutions based on several scenarios, this would help us. Sometimes we go to the field and we try to proceed with plan 1 or plan A, and something in the field is not going to allow us to do so, and the question is, what if I face this issue? Then this is going to trigger me to go to alternative B or alternative C, and the PMS management system report at the end would allow us to do that. There also would be a good coordination of work within utilities, as well as eventually, on top of all the benefits, is gonna benefit one major goal, which is doing the best possible job ever. Okay, underneath the payment management system, there are also some cities that they have maintenance management systems besides the payment management system. So this type of system is normally addresses routine and unprogrammed maintenance of pavements and all road and street components. Okay, now to give you a little bit more discussions here regarding the management system and how does it work from the managerial perspective. First of all, we have PMS administration. So it's really beyond engineering now. As you would see, PMS engineer would be somewhere in between the PMS administration and the PMS steering committee. Steering committee, you have to, as an engineer, you have to collect your data, present it in front of a committee, and this is how you proceed either with network level PMS or project level PMS. So when it comes to the network level PMS, we have to have the database, PMS database, which is gonna trigger for us data needs. So what do we need to collect? First of all, we need to collect inventory data. As I said before, inventory is basically general information about the road, the cross section, how many lanes, maybe traffic, and AADT and truck counts, as well as pavement performance. And I'm putting here an asterisk for the, what do I mean by pavement performance, is both functional as well as structural performance. And I mentioned this in chapter 1. To remind you one more time, the structural performance is how the structural is the pavement structure is sound enough, as it can resist the amount of traffic for several years to come, versus the functional performance is how smooth and safe to drive on that pavement structure. So there are two types of performances. The other data that we need to collect is also traffic data, which is eventually is gonna help us to come up with the best case scenario and fixing the roads. Then going now to the other aspect under the network level is MR&R, which refers to maintenance, reconstruction, and rehabilitation policies. So basically we need to come up with a matrix method or decision tree method or life cycle cost methods to fix and maintain the health of the network. So here the other part related to the PMS database systems, we need to address the personnel, the people that they are going to use the PMS database, the hardware, which are mainly computers and other measuring devices that we use in the field, as well as softwares. There are some softwares including Microsoft Excel, Access, and other softwares to include and measure and store all the data that we gathered from the field in one single software to predict the future performance of the pavements, all the way to users, which are engineers most of the times or technicians, that they will be handling all the collected data in one system, and how can we use it into the data analysis. From the other side also, we would need to look into several programs. How can we fix our roads from several perspectives? The very first one is it a single year prioritization or multi-year prioritization, or is it an optimization process? And we will discuss each one of those in the next slides. This is here an example of decision tree method. Very interesting, and this is a true life example that is used in some agencies to handle alligator or fatigue cracking. So let's go through this and try to understand what's going on here. So assuming that the major problem in our section is alligator or fatigue cracking, the question that's gonna come first is it a low severity, medium severity, or high severity? Once we identify the severity level based on the LTPP FHWA manual, then we are gonna go to the second stage, and let's now pick on, let's say, medium severity. So let's say the severity is medium. The next question would be the extent. Remember the difference. Severity is how bad is the crack itself in terms of the width of the crack, but the extent is the area. For example, if I have a section, 500 square feet section, if I have 400 square feet full of fatigue cracking, then this is a high extent, because I have 400 out of the 500 are affected by fatigue cracking. While if I just have 100 square feet over 500 square feet, this is a low extent. So for example, again, let's continue with our example here. If I have medium severity and low extent, then the decision tree is going to ask us to patch this piece and come up with a new patch, and this is the way to fix it if it's low extent. How about if it's medium extent? This is gonna trigger now a major rehabilitation, which is mainly 2 to 4 inches. How about if we assume it's low severity? Low severity, that means the width of the alligator fatigue cracking is very minimal, and also low extent. Low severity and low extent, that means do nothing. In fact, yeah, if it's low severity, low extent, you don't have much to do most of the time. Some other agencies that they would pick a very preventive maintenance, like a fox seal or a chip seal or slurry seal, but most of the agencies wouldn't do anything if everything is low severity and low extent. The very first condition that's gonna trigger an action is really here low severity and high extent, which is gonna trigger a surface treatment. Surface treatment again can be different types of treatments, microsurfacing, chip seal, slurry seal, or crack sealing. All those options can be handled under surface treatment. Okay, now let's go through the project level PMS. So when it comes to project level PMS, first of all, this is going to be handled by the materials division as well as the payment design division. Why these two? So materials division, this is going to deal with the mixed design. If I let's say in the past I used to have a problem with rutting. That means, as we discussed in chapter 1, I may have an issue with a lot of binder content or low air voids. Then I have to talk to the materials division to make sure that the mixed design, the next time, it has to address this issue and it's gonna fix it from now on. At the same time, the payment design division, which is the thickness, is going to define the thickness rather than the materials. So the payment design division also is going to look into the structural design and how can we come up with the adequate thickness to resist fatigue as well as rutting, cracking, for example. So based on these two divisions, it typically trigger two actions here. The very first one is in-depth investigation. And remember why it's in-depth investigation, because it's a project level. Project level concentrate on one single section, and now we really need to look into very detailed information regarding deflection testing. If I put certain load on the road, and now I'm gonna have strain gauges to measure how much deflection do I have to understand the stiffness of the road. Also, I need to do laboratory investigation. I would take a sample or a core, go to the lab, apply some tension or compression tests to know the performance of that road. I will also need to replicate the mix design. Sometimes, again, once we do the lab investigation on certain sample, I would heat it up and try to know and replicate the mix design and see what went wrong regarding any parameter in the mix design. Meanwhile, you would also required to do structural analysis to decide if you are gonna come up with an overlay design or a major reconstruction. Also, the question here, when you are looking into a project level PMS, you also have to think of the two options that you have available, which is either hot mix asphalt or Portland cement concrete, which is eventually is gonna come up with a final design recommendations to fix the issue. Okay, so again we're continuing in the overview. Now overview of principles and payment management systems. So analysis really tend to indicate that it costs the maintaining agency less to have good roads than bad roads if the roads are kept at any reasonable level of serviceability. So one more time, typically here again we tend to spend a lot of money, and this is the old school of thought, is to spend a lot of money in the old roads and leave the bad roads and leave the good roads until they deteriorate. But this is the old school of thought. Now we found out that it's good to spend a little bit amount of money for the good roads to keep them in that good condition all the time, so you won't need to spend eventually a lot of money on rehabilitation or major reconstruction. And the way to do this is really by following the preventive maintenance. So preventive maintenance are really specific treatments that they are applied to road surfaces, inadequately designed, may delay the required rehabilitation for a short period of time, but in the long run they will not be very cost effective. That's mainly what it is. So let's look at this chart right here, and from the chart we would be able to understand more that concept. So in the x-axis we have the payment age in years, 0, 5, 10, 15 and 20 years, while the y-axis has the payment condition from 0 all the way to 100. And now the idea here is to see the cost of every single maintenance. For example, if the payment condition was high, for example here all the way to maybe 75% of the initial condition, then we can still apply some minimal preventive maintenance. If we waited until now the condition of the payment is approaching 60%, now we need to do minor rehabilitation all the way to this point here, which is about 50 or 45, which is a moderate rehabilitation, which can go all the way to 2 or 3 inches overlay. Yet until this point it can cost us very minimal amount of dollars compared to if we waited until we hit that poor or very bad condition, where now we're gonna spend considerable amount of money to have a major reconstruction, which is 4 to 6 inches overlay, or a major reconstruction. So if for these maintenance activities, which are very minimal, each $1 spent here would really cost $3 to $5 if it's delayed to here, which is a major rehab, or it's gonna be $8 to $12 if it's delayed until we reach reconstruction. So maintenance of those roadway pavements in fair or better conditions costs significantly less than rehabilitating or reconstruction those in poor conditions. Another aspect that we also want to cover in today's lesson is the software. Some people and some engineers think software would manage the pavement network by itself, and the answer is no. Software really doesn't manage pavement or make decisions. You have to make decisions. Personnel in the organizations will have to manage the pavements and make decisions themselves. What the software will do is just gonna assist you in information management and decision support, but the major recommendation is gonna come from you. So to give you a clear understanding of what's going on here, we can see this flow chart. Well, here we have 3 different types of data go into the program. The very first thing is the road inventory, and I think I'm repeating a little bit myself, but it's good to stress on the fact that we have to get some general information about the road, and mainly the pavement condition survey and how the pavement is doing and what are the distresses observed on the streets, including for example fatigue, rutting, thermal cracking, and so on and so forth. And also, it's not just the type of distress, we need to know the extent as well as severity of each one of those problems, and eventually how can we repair it, and what are the strategies and the costs associated with each one of those fixations. So these three pieces of information is gonna feed into the basic components of the software. So once you have all these ready, now this is gonna generate a good reliable database, which is gonna help us to maintain a good data analysis, and eventually we will have a good engineering report, very well documented and very well supported by the repair strategies as well as the cost associated with all the alternatives that is being presented. So also another thing that I want to mention, that the payment management system really provides me to organize the massive amount of data that develop with pavement network. Imagine so many agencies, they measure the pavement distresses on their entire network every year, or sometimes in every other year. Imagine with 30 or 40 or 50 years worth of data, this can generate a lot of information. And back in the days, as this picture shows you, everything was in books, and just the payment management database would consume a lot of space, rooms and rooms of files, and even if we want to trigger something after 10 or 15 years, it would be impossible to retrieve this information in a timely fashion. And that's also why we have now softwares to manage all the information, to store a lot of information, but it's not just about storing, it's how to retrieve certain amount of information whenever you need it. And that's one of the really good benefits of having a payment management system. Another point that I want to point out here is the payment management systems is generally restricted to looking at the maintenance and rehabilitation needs for the existing payment system. It's very seldom considers the need for additional payment area to address increased traffic capacity. So this is totally different thing. So when we look at the payment management system, is how to maintain and rehabilitate the roads. If I have, as this picture shows you, I have much more increased traffic with time, which is going to trigger additional payment area. This has nothing to do with PMS. PMS is mainly to look into the maintenance and rehabilitation needs, and how can we fix and keep the health of the network in a good, healthy conditions. So, speaking of lots of information, yes, sometimes we face this issue with excessive data. Excessive data collection has created problems in implementing and continued use of PMS in the past. Sometimes, again, engineers would complain that there's a lot of data and excessive data, and they cannot even manage it in the best way. So, to avoid this problem, absolutely the minimum data are normally collected at the network level. So we don't have to collect every single information. If you are looking into the network level to have a general view of the network, then you will need to collect some minimal amount of data that's going to help you to do and perform the required analysis, but at the same time you are not going to be overwhelmed with the amount of data collected. So if you have this minimal amount of data in the network level, then the primary results would include the fund needs, the future conditions for various funding scenarios, as well as the prioritized listings of payment sections for maintenance and rehabilitation. While in the project level, the purpose is really now to provide the best maintenance or rehabilitation strategy possible for that defined section of payment for the available funds. So you see here the difference. Again, when it comes to project level, is more concentrated look in one section or in one project, and eventually our goal is to come up with that best maintenance or rehabilitation strategy to fix that road in particular. So you may ask me, if this is the case, do we need to collect more data when it comes to the project level? The answer is yes, but not all the data required for project level decisions are required for the network level decisions. So generally the network level decisions can be made using much less complete data than required for the project level. And that's another reason or another idea or another difference between the network level and the project level. The network level and the project. The project level. The project level requires much more information compared to the network level. So with that, I think now we're reaching a point we were able to see the huge difference between the project level and the network level. Project level, in summary, we look into more detailed look into one section at a time. We try to gather a lot of data, including inventory data, the road conditions. We take samples, we test them in the field, we test them in the lab as well, and then we try to gather the mixed design and the structural design divisions together to come up with the best technique. While the network level is less amount of data needed, it's a general look at the network to come up with some good decision with the minimal amount of data.